Welcome again to another video. My viewers and my subscribers, pleasant good afternoon to you. So in today's video, I'm going to be talking about the calculation of the slope, how to calculate the gradient of a slope. Now you know that working on a construction project, that not every time you're going to be working on a land that is flat. Oftentimes you're going to be working on a land that is slope, a land that is steep. So in order to accurately know how much that land has sloped, you have to calculate the gradient of that slope. So in this week's video, I am going to be demonstrating how you can go about calculating the gradient of a slope. So if you're working on a road project and you want to calculate the fall of a pipe, the slope of a pipe or the grade of a pipe, you can use this demonstration to do so. Also, if you're working on a road project and you want to calculate the super elevation of that road project or that road surface, you can use this method to calculate the gradient of a slope. But this video in particular is for the construction of a building or a house on a land that is slope, because oftentimes, especially in the hilly parishes, you're not going to end up with building on a land that is flat. So you're going to have to know how to calculate the steepness of that land to know how high the split level is going to be. So stay tuned for this video, and I hope you find the video interesting. In this presentation, I'm going to be taking you through how to calculate the gradient of a land that is slope. And as I've said to you before in my presentation earlier, in my intro earlier, that not every time you're going to be working on a land that is flat. At times you're going to be working on land that is slope, and you have to know how to deal with a land that is slope. So first of all, I'm going to teach you how to calculate the gradient of the slope. I'm going to teach you how to calculate this percentage slope and also the elevation of the slope. So if you imagine, if you're working on a piece of land like this, the land is sloped in this direction, right? Right? I am going to show you how to calculate all these three items: the gradient of the slope, the percentage of the slope, and the elevation. Right? So let's get into it. So therefore, this is the land here. The land is sloped down like this, right? And I'm going to tell you how to set up the different things so that you can obtain the height of your slope. So at the end of the land here, you're going to drive a wooden peg, right? And you're going to now have a person on the opposite end of the land with a 1x3 lat, and you're going to ensure that you use the line level to plumb this 1x3 lat, because if it is slanted, it's going to affect the reading of the gradient, and we don't want that. So ensure that the person who is holding the staff here at the end, this 1x3 board, or it can be a 2x4, ensure to have it plumb or vertically straight so we can get an accurate measurement. So you're going to know, after you put down your wooden peg here and your staff here, or your wooden lat, you're going to use your card line now, and you're going to put the card line at the base of the wooden peg here, and you're going to stretch it all along here, right? And wherever it levels, so you're going to level this line, right? Ensure that it's perfectly level, and where it is level, say for argument's sake, it is level at this point here, right? You're going to tie the car line here, and you're going to measure the distance from here all the way down to the base of the staff, right? So that measurement let's say for argument's sake that that measurement is equal to 10 feet, right? So it's a 10 feet drop, right? And you're going to measure the distance along here, right? So measure this distance with your tape measure, right? And some tape measure you can get them in 40 feet or 60 feet length, whatever the length might be, but ensure to measure the length here, the horizontal length here. So we're going to imagine that that length is 40 feet, right? So we have a 40 feet length and a 10 feet height. So what this is saying is that the land at the end right here have a maximum drop or slope of 10 feet. So I'm going to show you now how to calculate the percentage gradient of this slope here, right? So the percentage gradient is equal to the rise over the run. So the rise of 10 feet over the run of 40 feet, right? So the percentage slope, and you might hear me use slope and gradient, they are one of the same. So slope and gradient can be used interchangeably. It's the same thing, right? So the percentage slope or the percentage gradient, right, is equal to a rise of 10 feet and a run of 40 feet times 100. Right? So if we should work this out, this works out to be 25%. So right away we calculated that this slope of this land here is 25%, right? It's a 25% slope. So if you want to find out a particular distance along this line here, if you want to find out the height at that particular distance, all you have to do is time that distance by 25% and you end up with the height of that slope. So let's say for argument's sake we want to find out at the halfway point here, right? 20 feet. So we want to calculate the height or the elevation at 20 feet. So it's going to be the elevation is going to equal to 20 feet times 25%, and this equal to 20 feet times 0.25, right? And this now works out to be 5 feet. So the height, the elevation at 20 feet is going to be equivalent to 5 feet, right? The same can be said if you want to find a distance here of 10 feet. We do the same thing, right? We want to find the height here or the elevation there at 10 feet. So it's going to be 10 feet times 25%, and that is 10 feet times 0.25, and that is going to equal to 2.5 feet. So at 10 feet, the height of that elevation is 2.5 feet, right? .5 feet. And you can pretty much do this for the entire length of this line here. Any distance you want, you just times that by 25 feet and you arrive at the elevation. So there is an alternate way how you can calculate the slope. As a matter of fact, there are several different ways how you can calculate the slope, and I'm going to explore a couple of these alternates, right? So the gradient of this land is 10 feet over 40 feet. It has a rise of 10 feet and a run of 40 feet. So the gradient is really a rise of 10 feet and a run of 40 feet. So the gradient is really 1/4. So what this is saying is that for every 1 foot rise, there is a 4 feet run. Or every 4 feet run, there is a 1 foot rise. So this gradient is really a 1 in 4 gradient. So the gradient of this linear, the slope of this linear, right, is equal to a 1 in 4. So that means every 4 feet there's a 1 foot rise. So if you want to work out now a distance along this line here, so you want to work out 16 feet. I'm using even numbers now to make the calculation more easier. So say you want to work out 16 feet, and 16 feet would be some distance here, right? 16 feet, right? You want to find out the height of this slope here, right? The rise. So we know that 16 feet, right? We know that 4 feet, we can get 4 feet from 16 feet 4 times, right? 4 times, right? And we know that every 4 feet there is a 1 foot rise. So we times 4 by 1, so we know that the rise is equal to 4 feet, right? 4 feet. Because every 4 feet run, there is a 1 foot rise. So at 16 feet, we have a 4 feet height. And you pretty much can do that for basically any length along this line. So if we go back to our 20 feet, right, we're supposed to end up with that same 5 feet, 5 feet. So if it's 20 feet, we work out how many times we can get 4 feet out of 20 feet, and that is 5 times. And 5 times 1 is 5. So the rise at 20 feet, the run at 20 feet is equivalent to a rise of 5 feet. So that's one alternate. So I'm going to give you a second alternate. This alternate way or method, we are going to use similar triangle, right? So we're going to use the ratio of the big triangle in comparison to the ratio of the small triangle. So we have a big triangle here of length 40 feet by a height of 10 feet, right? And we want to find out the height at 20 feet, right? So we're going to take that as the small triangle, right? So the big triangle is going to be this 40 feet by 10 feet, and the small triangle is going to be 20 feet by x. So we need to solve for x, and solving for x at 20 feet, we must come back at our 5 feet at 20 feet, right? So if you should look at our calculation here, so the big triangle, we have 40 feet over 10 feet, which equal to the small triangle, which is 20 feet over x, right? So if we should cross multiply, right? So we are going to have x bracket 40 feet equal to 200, because 10 times 20 is 200. 200, right? So we solve for x, so x is going to equal to
200 divided by 40, right? And that is equivalent to 5 feet. So we come back at the 5 feet, right? Using the method that we use for the first example. So this is an alternate way how you can use similar triangle to come up with the gradient at a particular length of your land, right? So, right. And there's also another alternate method how you can calculate the slope of your land, right? This is a level, and when you measure this level, it measures, I think, 2 feet, right? This measures 2 feet, right? So if you should use this 2 feet, right? So in this method, you do not have to measure the entire length of 40 feet, right? You could just measure 2 feet away from this line here, right? You could just measure 2 feet away from this line here, a 2 feet length, and then whatever fall you have here, or height here for your rise, right? We know that every 2 feet, that is going to be equivalent to that amount of rise. So since we have a 1 in 4 run, 1 in 4 gradient for our slope here, and we know that if we're going to use a 2 feet run, is going to equivalent to a ½ inch rise. So I'm going to show you now how I can arrive at my 40 feet length and get back my 10 feet rise. So we know that every 2 feet there's a ½ inch fall or a ½ inch rise, right? So we have to find out how much 2 feet is in 20 feet, is in 40 feet. So we have 40 feet divided by 2 feet, and that is 20 feet, right? 20, right? So every 20 feet we have a ½ inch, right? So it's going to be 20 feet times 0.5, right? And that is going to equal to 10 feet, right? So we get back our 10 feet. So as I'm saying to you before, you do not have to measure the entire length here. You only can measure if you want to be as, less time consuming. Just measure 2 feet here and you measure the rise. And so you have to find out how much 2 feet is in the 40 feet and you times that by that rise, and you're supposed to get back the maximum height. So in this case it was 40 feet. So we find out how much 2 feet is in 40 feet, which is 20, and we times 20 by 0.5 and ended up back with our 10. Okay? There's an important point that I want to point out to you before I end this video. And I have seen it happen on site already, that when you level this line with your line level or your level, there's a tendency to measure the slope distance to obtain the length of that said piece of land. That is not right, because the slope distance here, right? The slope distance here is going to be longer than the horizontal distance here by a slight margin, and I'm going to prove to you. So ensure when you level this line, measure along this line here, right? Do not measure the slope distance, because the slope distance is going to be a little bit longer, and that is going to affect the gradient of your slope. So in order to be accurate, measure this horizontal line here, and I'm going to show you that this line here works out to be a little bit longer. So what we have here is this, essentially, right? A right angle triangle, 40 feet here, right? 40 feet here in run and a 10 feet high. So if you want to find the distance of this line, so we can call the distance of this line x, right? So we know x squared is going to equal to the sum of these two sides squared, right? So it's going to be x squared which is going to equal to 40 square plus 10 square, right? So x square is going to equal 1600 plus 100, right? So x square is going to equal to the roots of 1600 plus 100, which is going to be 1700, and then x is going to equal to 41 feet. So this distance here is going to equal to 41 feet, right? So you can see that is 1 foot longer than the horizontal distance of 40 feet. So ensure not to measure the slope distance, because it's going to be a little bit longer than the true horizontal distance. So this is a knowledge that if you're working on a slope plan, you must try and understand it, because you're not going to be able to tell the elevation of your land if you can't accurately calculate this. And one thing before I go, if you have a surveyor on site and your surveyor give you the elevation here, to be, for example, 200.16 feet, right? If you want to find the elevation all along here, it is easy because you already have the height of your slope. So the elevation of at the point of 5 feet is going to be 5 feet minus this 200.16. So the elevation here is going to equal to 195.16, right? And the elevation here at the base, right? Elevation. The height here is 10 feet. So you subtract 10 feet from your 200, and that's going to give you 190.16 feet. So you also can calculate your elevation all along the slope line here just by doing the elevation of the height of the rise, right? So this is a critical piece of information that I think you should understand if you're a builder or a contractor or a student or a site manager, to properly calculate the gradient of your slope or the percentage of your slope to accurately know how high each point is along that slope. So if you're putting in a split level, you know how much material to cut, right? So that is it for this video. I hope you find the video informative and interesting, and if you like the video, please hit the like button. Do remember to subscribe, and I will see you in another video upload. Thank you.